Everyone, welcome back. In the last two chapters, we learned about the core model in chapter 1 and the AI expert, which is AI experts that understand images. And in the second chapter, dataset, we talk about the study material which is used to train or evaluate that expert. So we give the example like how the student as well as these AI models are complementary to each other. And we saw how to load the model and how to structure data for the training. So we talk about how this model works. We talk about the usually we talk about the data set and how we use the YAML file for this process. And now imagine you are working with your model and data set, and you need to perform various helpful tasks that are not part of the core train or predict process. So for example, maybe you need to check if your data set is correctly formatted before training or not, or download a model file from the internet, or draw the results of the prediction onto an image. So this is where the utilities come in. What are these utilities? So think of the utilities in Ultralytics as a collection of handy tools that help you with common tasks related to computer vision projects, but which don't fit nearly into categories of model, dataset, or trainer. It is like having a versatile toolbox filled with screwdrivers, wrenches, and measuring tapes. You use them to support the main building project, that is training or using your AI model. So these tools, they are the helper function for pre-processing, post-processing, and more. They also simplify the tasks like data augmentation or result parsing. Also they include tools for the image resizing and the bounding box manipulation. So as I mentioned, these are the handy tools that can help you. These utilities cover a wide range of functions. For example, checking things like making sure these required libraries are installed or not, and verifying the file paths or formats. So for example, the file path of image or the training directories or other. And another is handling file and paths, which includes downloading files, joining other parts correctly. Data prevention and helps to split data set, like converting annotation format like bounding boxes. Whereas visualization, they are used for plotting results and drawing the boxes or marks on the image. Whereas other activities includes like printing message in different color or speed and other. It helps in profiling the code speed as well. So let's look at a bit of examples now. So visualizing the dataset annotation. So before we spend hours training a model, it is a great idea to check if our dataset levels are correct or not. Therefore, a utility function can help you visualize these annotations directly on the images from your dataset to spot errors early. So Ultralytics, they provide a utility for this. You give it a image path. The path to its corresponding label file like .txt as well. We provide both image path as well as label path. As well as we also provide the name classes by my class names. We see here 0 belongs to it is a dictionary. 0 is car, 1 is person, 2 is boss. Here is key and values. So next, it will draw the boxes or marks and class names on the image. So here is how we can use it, as I mentioned here. So these visualize image annotation. This line imports the specific utility function we need. This is a dictionary, as I mentioned, mapping the number used in the model or library or the labels. Whereas this visual image annotation, this is the call to the utility function. We have this visualize image annotation from this directory we have imported before, and now we are using these functions and we are passing the different parameters or parameters like path to the image, label path, as well as the classes. The function does the work of reading the image, right? And they will also read the label file and interpret the coordinates, and later it will draw everything onto the image. So this will really save us lot of time coding ourselves, because we can just look at the labels. So this will really help to visualize or check our labels whether it is correct or not. So next is, as we mentioned, first it helps in visualizing data set, like for example we are passing images as well as directly, and we are looking whether it is working or not. Next we will be checking about the converting bounding box formats. So for example this is the format we'll be talking it. So in chapter 1 we talk about the model. When we set the model gives us the prediction like results which contain transformation like boundary box coordinates. We look at the boundary box in the first image, which is really a box which the box is created by using the coordinates, and these coordinates can come in different format. For example we can have format 1 and format 2 here. So which is like we have top left x, top left y, these are the corner coordinates, and bottom right x and bottom right y coordinates. So if we have two coordinates, diagonal coordinates, then we can create a diagonal or a bounding box. Also we can use center coordinate and height and width to make a box. So these are the two ways or two format. So, but often we need to convert these formats depending on what we want to do with these boxes. So for example some plotting libraries prefer this xx xyxy, while the YOLO labels, this YOLO will use this xywh as format. So from this alternatives we will be exporting this format or structure. This numpy, as I believe everyone know, this is numpy is used for array functions, and we are often using here to for the numerical data like box coordinate using this numpy arrays. So now next we are importing our specific conversion functions, like in format 1 and format 2 it will be understand because we are importing that and we will be using later. And next let's say we have a box in xy format from a model prediction. So we are providing that value. We create a sample box right here as a numpy array. It is a list of lists, we can see to bracket. So this makes possible for creating the multiple boxes, because we can have different dimensional values. So we have a two dimension array here. And next we have this xyws box, which is which has to convert this one format to another. Just it will be calculating our center by dividing, like we have x1 here, x1 and x2, x1 plus x2 by 2 and y1 plus y2 by 2, and in that process it will calculate the center x and center y, whereas it will be calculating height and width by using like y2 minus y1 and x2 minus x1 like that, and it will be converting into the next format, in this format, in this format. So because as we talk about this YOLO understand this version, so we are converting this. And generally we also can convert it back to the another step, like we can convert from one to another and another to other. So this is like a vice versa. So how is it working? Unlike a model or trainer which involve complex process or internal states, most utility functions are relatively simple, we can see, because in other processes when we talk about the model or the dataset it was a very long loop, because in these utilities they are designed to perform one specific task well. So now first as a user you will be calling the utility function by passing the required inputs like file path or the coordinates. So like file path and coordinates, we also talk about coordinates formats. Then the utility function, this utility function will execute its predefined set of instructions using these inputs. So we are calling the function by passing the input data, and it will read or process the input data first, and it performs the tasks like reading files, doing the calculation, drawing an image, and like calculation, drawing, etc. And later, after all the process has completed, it provides the results, a modified image or a new set of coordinates, and confirmation of success to our script. This is not a complex utility object being created or managed in the background like the YOLO object for a module. You are simply calling the functions when you need it, right? And so this is a diagram that is illustrating here. So we can have many things like math and array operations like box conversions, as we talk here. We also can have file and path operations requiring checks and environmental detection, might be in sort in Python files. So these are to make ensure that the files exist. Also helping in the visualization and plotting, as discussed earlier. Additionally, it is also helping in dataset specific helpers like visualizing annotation or splitting data for training or training and validation, like that. So but don't worry, you don't need to know exactly which file every utility lives in. So like for example, if you are using VS Code like me, you can usually it can your id VS Code can usually help you find where the function is important from, or you can refer to this Alternalytics documentation from the GitHub. The key is knowing that if you have a common computer vision task, there might be a handy function for it in the utilities. Okay, so to conclude, we explore the utilities abstraction in Alternalytics, understanding it as a diverse toolbox of helpful functions. So we saw how utilities can assist with tasks like visualizing dataset annotations to ensure data quality and converting bounding box formats for different needs. These functions simplify common operations and support the main workflows of using models and datasets. While models and datasets are about the core AI expert and its study material, utilities are the essential tools you use alongside them to prepare data, also to visualize a result, understand things. As a whole, you are managing the project more efficiently. So now that we have covered the model, the export, the data set, which is the study material, and the utilities, which is nothing but the toolbox, we are ready to look at how we can configure the training process itself. For that, in the next chapter, we will be talking about the configuration. In short, it is known as CFG in chapter 4, which allows us to control the settings and hyperparameters for the tasks like training.